When shopping for clothes, you can find shirts that say one size fits all. Well, unfortunately for us, that three-tier network design doesn't fit every size. By the end of our time here together, we will be able to describe two-tier network designs. That three-tier architecture where we have a dedicated core switch, that is phenomenal for enterprise networks. The largest networks out there, they are relying heavily on that model. However, when we think about smaller organizations, do we really need a dedicated core layer? And the answer is typically no. So in this video, we want to explore how exactly we can collapse those layers down from 3 tiers to 2, therefore giving us a better fitting architecture at a more affordable cost. When we've mapped out the 3-tier design, we've looked at the fact that typically we have a set of functions. So the core, distribution, and access layer, they have different functions. And again, this was covered largely in that hierarchical network model skill. So if you didn't see that as part of this playlist, be sure to go watch those videos because we go into detail about how, for example, the core has a list of functions, the distribution layer has a list of functions, the access layer has roles and responsibilities. And we need to understand this concept of collapsing. Because if we collapse 2 layers together, like let's say we're going to collapse the distribution and access layer together, what we're really doing is creating one network block that has both of these sets of responsibilities. For example, we might have a collapsed distribution and access layer such that we have the SVIs for a building, but we also directly connect phones and users, etc., to this particular set of switches. And so really we've collapsed distribution and access into one, and potentially that links out to a core switch somewhere. The other possibility is that we don't actually have a true core layer in this design. Maybe a distribution and access switch collapsed together is enough to give us connectivity to the local building, and then we can bring in the internet, and we can bring in security services, and whatever it is that we need to bring into this network. If, for example, this is the entirety of our network where we only have a pair of switches connecting some number of phones and users, and we've got all of the services connecting in, well, we don't need a multi-tiered architecture at all. One pair of network switches might be enough. However, let's grow it out from that a little bit. Let's say we have a building with multiple floors, and each one of those floors is going to have some number of users. So typically what we're going to do is deploy access switches to every one of those floors. And one of those floors, maybe we end up having that distribution switch. That distribution switch brings in the internet, it brings in WAN connections and some of these other network blocks we're used to seeing. And hey, maybe users directly attached to this distribution switch, such that now it's a distribution access, or maybe we even have dedicated access switches connecting to the distribution switch. But hey, either way, we're collapsing this design so we don't need distinct core, distribution, and access switches. In this example, what we've done is we've collapsed the core into this distribution switch. And so as we can see, we can collapse different directions. We could collapse the core and distribution together. We could collapse the distribution and access together. And hey, you guessed it, we could collapse all 3 of them together, core, distribution, and access, in a really small environment, as we saw with our first example. So as we talk through different design options, we're going to find that the user count can be independent of what's considered a large or small network. For example, if we have, let's say, 2,000 users, some of us might assume that, oh, hey, you know what? That's enough for a 3-tier architecture. Let's go ahead and build that true core layer in because we've got so many users. Well, if all of those users exist at one building, and this one building, maybe it's our headquarters, has a lot of different floors, we're going to do what we did on the previous drawing, where we have access switches throughout, we have distribution switches, and you know what? We might as well collapse the core and distribution together because we don't have a whole lot of need to bring multiple distribution layers into one another. Meanwhile, we might have a network of 1,000 users, and the 1,000 users consists of a campus of multiple buildings. And as we scale out to multiple buildings, well, all of a sudden, we might need a true core switch to bring in these multiple buildings. But even this can be a little gray, because while we might have distribution switches at these 4 perimeter buildings, inside the core building, well, we might actually have a collapsed distribution and core switch tied to the access switches within that building. Because what we're doing is we're bringing those 4 other switches into that one core distribution switch and allowing this switch to not only do the fast layer 3 switching that we need among these different locations, but also to do the SVIs and the other services that we're expecting for this building and these users. As such, we might expect that the internet and the WAN circuits, if we have those are going to come into this same pair of switches. And again, even though we do have a 3-tiered architecture coming from the middle building out to the access layer that are at other locations. But within that building, we are collapsing the core and distribution layers into one set of switches. So one of the key questions to ask is, how many distribution blocks do we have? If we have multiple distribution blocks, then typically it's going to require some kind of core design. And the more network locations we have, for example, if we have a data center hanging off of here as well, that's all the more justification for true core switches. Because we don't want our core switches to be bogged down by the distribution services. We want them focused on that layer 3 switching. But as we've seen here as well, simply the physical layout of a network can drive the network design. Because again, here we have 5 different buildings, and over here we have 1 building. Even though we've got twice as many users here on the left, the fact that we only have 1 building drives the design and allows us to collapse these 2 switch layers into one another. Now, I've done a lot of network designs over the years, and I have to say that it's always a tug of war. Nobody has an infinite budget, whether you're working for an organization and they're coming to you for information, or whether you're a consultant going to multiple clients and they're asking for your help. Regardless of the situation, if you're doing network designs, we have to find the balance between the best and the ultimate network, which would be that true core layer and all of that, versus the, hey, we've got a budget and we have to have an affordable network. But we don't want to go too small so that now we have troubleshooting issues and network constraints and problems with redundancy. So it's all about finding that balance, saying, hey, what is our budget? How do we match the network needs to that budget as best we can? And sometimes we might start with a collapsed core and distribution and say, you know what, as this network grows, if we're looking at putting new sites out there or whatever the situation is, we can always add a true core layer later down the road. So if there's any question about whether to collapse or not, look at the options and say, hey, could we just move to a layer 3 core down the road in the future if it makes sense to do so? So again, when it comes to network designs, it's a lot of fun to do network designs, let's be honest. But when we're doing it, we have to take those 2 constraints into account and always look for the best solution for the need. And with that, you are now able to describe 2-tier network designs. I hope this has been informative for you, and I'd like to thank you for viewing.